Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says sort in a specific order. So, given an array ARR of positive integers, you have to sort them so that the first part of the array consists odd numbers and sorted in descending order, and the rest portion contains even numbers and sorted in ascending order. So, it's pretty simple explanation. We are given an array and we take out the odd and we sort it in the descending, and the rest later part is all evens sorted in ascending. That's cool. Same goes with example 2. I'll not reiterate the example, but how can we do this is by taking the extra space, but that is not allowed in a time complexity. Initially, naive approach can be one thing that we take out all the even numbers out and we place them in such a way that it is sorted and stored it within the array. But now we don't have an even and odd concept. We just want odds first and then evens later, and that too in a sorted manner. I'll break down this portion into two halves. One is partition and next is sorting. This would lessen our burden a bit, that we don't have to sort while partitioning and we can do it later part as well. So how can we partition these things without using any extra space? So we have one clear thing, that the left hand side are odd numbers and the right hand side are even numbers. So we have an even and odd insertion points. Why just can't we go ahead and maintain two insertion points and insert whatever element we find within an array? What I mean is, if I find an element within an array and I know if it is odd, then I'll go ahead and insert it into the odd insertion point. Or if I found any element within an array which is even, I'll insert it in the even insertion point. So in that case, any unknown element I can go ahead and insert either in odd or even. Once I'm done that, I can very well sort the partitions, and that is what required from us. Within 2 steps we go ahead and we can solve the solution. So one is partition and later is sorting. We don't need to return anything since it's a void and we need to do it in place. So let's begin with partition first. I have a partition with L is equal to 0, R is equal to dot length, and these are nothing but the indices of insertion point odd, and this is insertion point even. Insert even point. So I have insertion points of even and odd. What I'll do is I'll take a while loop. I'll go from left to right. Left is less than or equal to R, and I'll check whether if a coming element which is even or odd. So if it is odd, then I'll do certain actions, else if for even, I'll do certain actions. So far so good. So now if I'm if I'm even, what I'll do is I have an insertion point. I'll insert that element into that index. How would I insert? I would just swap this with the current element, which is Lth element, and the insertion point of even, which is R. Once I have inserted, my insertion pointer updates itself because I have inserted an element over there. So it is something like this. Now R was at this position. I have inserted E over here. Now I wanted to remove the pointer. I can go ahead and consider this as an insertion point. And if the movement comes here, like L, like let's suppose so L has this as even, I'll go ahead, I'll swap this E with this question mark, and this question mark would come over here, and the process repeats itself again and again. What if I see a odd number here? So if I'm having an odd number, I'll go ahead and insert this element into odd point. So swap a l comma l. So this is what I wanted to do. L is an iterator as well, and L is an insertion point as well. So this is a useless statement right now, so I don't want it to do this. I am assuming I have already made the choice, and I'm updating the pointer. Okay, that's cool. At the end of this loop, I know that my array is partition. Now I wanted to sort it. How would I sort it? So let's understand how it is partitioned. So what all even elements I have? Let's first stay with odd. Odd I have from 0 to r, right? Because r is the element, or L is the element where I have no more elements left, and L is the insertion point. So I'll just say r for now, and even is from r plus 1 to end. End means a dot length. So right now from 0 to r I have both inclusive, I'll say, and to length minus 1, both inclusive. If I tell in the non-inclusive manner, then 0 is included and r is not, r plus 1 is not. And if I tell it the same thing here r plus 1 is included and a dot length is not. And the same thing, we would be going ahead and sorting this one. Arrays dot sort, I'll sort a from 0 to r plus 1. Remember, the last index is excluded within the sort function of Java. So arrays dot sort, I'll do same with a r plus 1 a dot length. Now I want initial elements which are odds to be in a descending manner. I'll just use collections dot reverse order. I'm not sure this would work or not because it works with wrapper classes. Let's check this once. Maybe it will fail. Let's compile this and understand. Okay, I don't have swap and the sort method fails. Interesting. I'll quickly go ahead and implement swap method. So void swap, it will take int a, int I, int j. So int t is equal to a of I is equal to a of j, a of j is equal to t. So like this I'll swap it. If I don't have reverse swapping, I'll just remove them. And what I'll do instead is I wanted to reverse it. Verse 0 to r. Now L is equal to 0 while L is less than or equal to r. Equal to is not required, and I'll swap a l r with l plus plus and r minus minus. Why I'm doing this? Because I wanted to convert the ascending to descending. So this will give me an ascending. I wanted to convert into descending. That's the only thing, nothing much. So once I completed this, it passes the sample test cases. I'll try to submit this, and it very well passes. Okay, so it passed the rest all test cases, and this was a problem with arrays. So it was asked in Zoho and Microsoft, and the topic included sorting, arrays, and algorithms. So this was all about it. For more such array content, click the video on your right, and I'll see you in the next one.